We're talking about Lussac'S law. Lussac'S law. Lussac'S law of combining volume states that when gas react, they do so in volume, which bear in simple ratio to one another and to the volume of the product if gaseous, provided that the temperature and pressure remains constant. So what am I trying to say? It means when gas reacts, the reaction of the gas has to do with their volume. It has to do, it's in proportion to their volume. So when gas reacts, it has to do with their volume, and then not just volume, the volume of combination of the gas that reacts together it also depends on the volume of the product of the gas that I'm going to have. Let's say for instance, I have gas A reacting with gas B. Don't forget, it's a gas. You see something like a bracket here open and then G will be there. And then see another one open, then G will be there. And then giving me gas C, G will be here. And then giving me gas what? D, gas D, then G will be here. Please note, gas law are only applicable to gases. If you see something like, instead of G to be here, then they put S here. And then I say which is solid. State of the solid. And then I say if you apply gas law, no, it won't work out. Gas law is only applicable to solid. If they put it to gas, so if they change it solid and then they put L here, which is liquid, and they say you should use gas law, it won't work out. So they must all be in the same state. All of them must be in the same state, which is what? Which is gas. Even if they change this one and change it to AQ, which is aqueous solution, AQ, it won't work out. Whether this one is AQ or everything is AQ or two of it is aqueous solution, no, it won't work out. So for you to use gas, Lussac'S law or apply gas law to a problem, they must all be gas. This is a gas, this is a gas, and this is a what? And this is a gas. So when they react together, if I have 2 more here, if I have 3 more here, I have 4 more here, I have 6 more here. What it means is that if 2 mole of A react with 2 mole of B, I'm going to have 4 mole of C and 4 mole of D. So it's in proportion to their volume. So when gas reacts, this mole is the combining of these gases has to do with their what? Has to do with their mole. Let's take a look at the first example. Calculate the volume of oxygen required to burn 500 centimeter cube of methane completely. Now, I have methane being burnt in oxygen. You remember that methane is an hydrocarbon which belongs to an alkane family, alkane homologous series. And when all alkane, whether it is methane, ethane, propane, or octane, when they are burnt in air, they are burnt in oxygen, they always give one product, which is carbon dioxide and water. So you have to know this. You have to know this. You know there's no any equation for reaction here, so they expect you to know that. So oxygen is reacted with what? Methane. I have methane, CH4, reacted with what? Oxygen. What's my product? All methane or alkane family, they always burnt in air to give what? Carbon dioxide and water. Don't forget, all of them must be in the same state, which is what? Gas. So methane is a gas, oxygen is a gas, the carbon dioxide here is a gas, and the water we are talking about here is not a solid, it's not ice, it's not a liquid like your normal water. It's a gas, which is a steam. It's a gas. They must be in the same state. Immediately you are done with the equation, then the next thing that comes to your head is how to balance this equation. Because remember I said with volume, that's how they react. So we are going to balance the equation. I have 4 hydrogen here, I have 2 hydrogen here, then I can put 2 here. So I have 4 hydrogen, 4 hydrogen. That one is balanced. If I come here, I have 2 plus 2, 4 oxygen. 2 plus 2, 4 oxygen. And if I come here, I have 2, I can put 2 here. That is 2 times 2, 4 oxygen. And if I look at my carbon, is my carbon balance? Yes. So let's confirm now. 1 carbon is here, 1 carbon is here, 4 hydrogen is here, 2 times 2, 4 hydrogen is here, then 2 times 2, 4 oxygen is here, then these 2 will affect this oxygen. That's 2 oxygen here, and there's 2 oxygen here. 2 plus 2 will give you what? 4. So it means the atoms are balanced. Don't forget, it means 1 mole of methane will react with 2 mole of oxygen to give 1 mole of CO2, 1 mole of CO2 and what? 2 mole of water. So that is based on Avogadro's law, and and reacting this with Lussac'S law is the same thing as saying 1 volume of methane will react with what? 2 volume of oxygen to give 1 volume of carbon dioxide and what? 2 volume of water. Don't forget that Lussac'S law talks about volume. So we call it Lussac'S law of combining volume of a gas, how they combine together. So we have 1 here, there's nothing here. We have 2 here, we have 1 here, then we have 2 here. And don't forget that Lussac'S law say that equal volume of all gases, they at the same temperature and pressure contain the same number of molecules. So as long as they have equal volume, so contain the same number of molecules. So volumes and mole are related to each other. So we have 1 mole, we have 2 mole, we have 1 mole, we have 2 mole. So let's go back to the question. This is based on the chemical equation. Now we'll go back to the question. What's the question saying? The question says, calculate the volume of oxygen. So we are looking for the volume of oxygen. That one is unknown. There's a star here. Required to burn 500 centimeter cube of methane. What is the amount of methane? Volume of methane produced given. We have 500 centimeter cube of methane given. So they want me to find what is the volume of oxygen needed to burn this 500 centimeter cube of methane. 500 centimeter cube of methane. Now, this is analysis, critical thinking. You don't need to stress yourself. Just look at it. 1 volume, 2 volume. If 1 volume of methane, we need 2 volume of oxygen before a reaction occur. 1 volume of methane, we need 2 volume of oxygen before a reaction occur. Now look at it. 500 centimeter cube of methane, we need how many volume of oxygen? Definitely 1,000. This is 1:2. For this reaction to occur, 1 volume of methane must react with 2 volume of oxygen. And how 500 centimeter cube of methane produced? It is twice of it. Yes or no? And then the volume of oxygen produced is what? Needed to react is what? 1,000 centimeter cube. Now the next thing is, what is the volume of CO2 produced? It's also 1 volume. And what is 1 volume? 1 volume is 500 centimeter cube. And then what is the volume of steam produced? Is also 1,000 centimeter cube. So this is reacting mole. This is the combining volume, and this is reaction. What we have here, reaction. Let's take a look at from here now. It is done. Now the volume of oxygen required. Volume of oxygen required is what? 1,000 centimeter cube. And the volume of carbon dioxide. Volume of carbon dioxide produced is what? 500 centimeter cube. Let's take a look at example 2.